I once tried to find an iceberg video about space on YouTube, and guess what? I came up empty-handed. I get why. Space is a mind-bogglingly complex topic, both to grasp and to explain. It's easy to slip up and make mistakes which could spark a firestorm in the comments from the know-it-alls. No big deal if no one wants to take on that kind of responsibility. So, let me present to you my take. An iceberg of cosmic horrors. Yes, there might be some errors, oversimplifications, or shaky explanations here. I'm not claiming to be the ultimate authority. You can find plenty of videos on YouTube with deeper dives into these topics. We're just here to have fun, and maybe learn a little something along the way. Level 1. The tip of the iceberg. The ninth planet. The ninth planet is a hypothetical massive celestial body lurking on the fringes of our solar system. Astronomers came up with this idea to explain weird gravitational anomalies spotted in the Kuiper Belt, a region of icy objects beyond Neptune's orbit. Some of these far-out objects have bizarre, stretched-out orbits that can't be fully explained by the pull of the known planets. To account for these odd paths, scientists propose the existence of a massive, unseen planet tugging on these objects. If this planet is real, it's likely a gas giant, with a mass 5 to 10 times that of Earth. Its orbit around the Sun is thought to be incredibly distant, anywhere from 400 to 800 astronomical units. For context, 1 astronomical unit is roughly the distance from Earth to the Sun. At that kind of distance, the ninth planet would take 10,000 to 20,000 years to complete a single orbit. Right now, researchers are scouring the skies for direct evidence of this mysterious planet. They're analyzing observational data, running simulations, and trying to pinpoint its possible location. If it's found, it could revolutionize our understanding of how the solar system formed. The Big Bang. The Big Bang theory is the leading explanation for the origin of the universe. According to this model, about 13.8 billion years ago, the universe burst into existence from an infinitely small, dense, and scorching hot state, then rapidly expanded. This wasn't an explosion in space, it was the expansion of space itself. The intense energy and extreme temperatures allowed the simplest particles, like quarks and electrons, to form, eventually combining into atoms, stars, and galaxies. One of the strongest pieces of evidence for the Big Bang is the cosmic microwave background radiation, discovered in 1965. This faint glow of radiation fills the universe and is like an echo of the Big Bang, preserved from when the universe was just a fiery infant. The cosmic microwave background gives scientists a snapshot of the universe at about 380,000 years old, revealing how matter began clumping into the structures that later became galaxies. Another key piece of evidence came from Edwin Hubble, who found that galaxies are moving away from us, and the farther they are, the faster they're receding. This pattern supports the idea of an expanding universe that started from a compact state. The Big Bang theory keeps evolving with new observations, shaping our understanding of the universe's origin, structure, and future. But questions like what caused the Big Bang, or what, if anything, existed before it, remain wide-open mysteries in cosmology. Tabby's star. Tabby's star, officially known as KIC 8462852, yeah, not the catchiest name, grabbed headlines in 2015 for its bizarre fluctuations in brightness. Located about 1,500 light-years away in the constellation Cygnus, this star dims irregularly, sometimes by as much as 22%, far more than typical for stars of its type. This odd behavior was first noticed by astronomer Tabitha Boyajian and her team, using data from the Kepler Space Telescope. Early theories ranged from swarms of comets to, get this, an alien megastructure. The idea of extraterrestrials, though far-fetched, sparked massive intrigue, with some speculating that an advanced civilization might have built a giant structure, like a Dyson sphere, to harvest the star's energy. But follow-up studies poured cold water on that theory. no signs of intelligent life were found. The leading explanation now points to a massive cloud of dust or debris from a shattered planet or asteroid causing the unusual dimming. Observations show that the brightness changes depend on wavelength, which fits the idea of light being blocked by dust particles rather than a solid structure or alien tech. Still, no single theory fully explains the star's wild, chaotic dips in brightness. Pioneer plaques. The Pioneer plaques are humanity's message in a bottle, sent aboard the Pioneer 10 and Pioneer 11 spacecraft, launched in 1972 and 1973. Made of gold anodized aluminum, these plaques are engraved with symbols designed to share basic info about humanity and Earth with any extraterrestrial finders. The goal? To give potential alien civilizations a clue about who sent these probes and where they came from. The design is elegantly simple, yet profound. It features a nude man and woman standing next to the spacecraft for scale. The man raises a hand in a friendly gesture, while the woman's pose is calm, balancing the genders and avoiding any hint of aggression. Nearby, there's a diagram of the hydrogen atom, the universe's most common element, serving as a universal reference for time and distance units used on the plaque. Another key feature is a map of our solar system, with a line pointing to Earth as the probe's origin. The plaque also shows 14 lines radiating from the Sun, each tied to the unique frequency of a pulsar. These frequencies could help aliens pinpoint our solar system's location in the galaxy. Uranus on its side. Uranus stands out in our solar system because it spins on its side. Unlike most planets, which rotate roughly perpendicular to their orbital plane, Uranus has an extreme axial tilt of about 98 degrees. This means that for much of its orbit, one of its poles points almost directly at the Sun, creating a bizarre seasonal cycle. Each pole gets about 42 years of continuous sunlight, followed by 42 years of darkness. Uranus takes 84 years to orbit the Sun, and scientists think this wild tilt might stem from a massive collision with another celestial body early in its history. That cosmic crash could have knocked Uranus onto its side, drastically altering its orientation. This odd rotation affects everything on the planet, including its magnetic field, which is also tilted and off-center. This creates a chaotic magnetic environment and a unique magnetosphere. The tilt also messes with Uranus's atmosphere, with each pole's prolonged exposure to sunlight causing extreme seasonal swings. Scientists are still studying the planet's atmospheric makeup and weather to understand how these long summers and winters shape Uranus, making it one of the most enigmatic and fascinating planets in our solar system. Tesla Roadster. In February 2018, SpaceX, Elon Musk's company, launched a cherry-red Tesla Roadster into space aboard a Falcon Heavy rocket. Originally Musk's personal car, the Roadster was used as an unconventional payload for the rocket's test flight. Inside, they strapped in a mannequin in a spacesuit, dubbed Starman. This quirky stunt captured the world's attention, blending spectacle with a bold symbol of humanity's cosmic ambitions. The Roadster's journey is no ordinary orbit around Earth. It was sent into an elliptical orbit around the Sun, stretching out to the distance of Mars' orbit. Now, the car and its dummy driver cruise through space, zipping between Earth and Mars over vast distances. Scientists estimate the Tesla could keep orbiting the Sun for millions of years, though the harsh space environment, cosmic radiation, and micrometeorite impacts will gradually break it down. Voyager Golden Records. The Voyager Golden Records are two phonograph discs launched aboard Voyager 1 and Voyager 2 in 1977, designed as a cosmic greeting card for any alien civilizations that might encounter the probes. Each record is a time capsule, packed with sounds and images meant to showcase the diversity of life and culture on Earth. The records include 115 images, natural sounds like thunder, animal calls, and ocean waves, plus a musical anthology spanning cultures and genres, from Bach and Beethoven to traditional music from Africa, China, and Peru. They also feature greetings in 55 languages and a message of peace from U.S. President Jimmy Carter. One touching detail is a recording of brainwaves from Anne Druyan, a project team member, captured as she thought about love and the universe. Made of gold-plated copper, the records are built to survive billions of years in space. They're housed in protective aluminum cases, engraved with symbols and instructions to help potential finders play the contents. The records also include a pulsar map to show Earth's location in the galaxy. Since Voyager 1 and 2 left our solar system, they've become the farthest human-made objects ever, carrying our story into the cosmos. String theory. String theory is a branch of theoretical physics that explores how objects interact not as point-like particles, but as tiny, one-dimensional strings. Unlike traditional particle physics, which treats particles like electrons or quarks as dots, string theory suggests these particles are actually minuscule vibrating strings. These strings are so tiny, estimated at 10 to the negative 35th power meters, known as the Planck length, that they appear point-like at observable scales. The way these strings vibrate determines a particle's properties, like mass and charge, much like different notes come from a guitar string depending on its frequency. The big draw of string theory is that it naturally incorporates gravity, something traditional quantum physics and Einstein's relativity struggle to reconcile. This has some physicists hopeful it could be a theory of everything, uniting all fundamental forces, gravity, electromagnetism, and the strong and weak nuclear forces, into one framework. A quirky feature of string theory is its need for extra spatial dimensions beyond the familiar 3. Most versions require 10 or 11 dimensions for the math to work. Since we don't see these extra dimensions in daily life, theorists suggest they're compactified, or curled up at scales too small for us to detect. The WOW signal. The WOW signal is one of the most famous mysteries in the search for extraterrestrial intelligence. Detected on August 15, 1977, by astronomer Jerry Amon using the Big Ear radio telescope at Ohio State University, this powerful narrowband signal lasted 72 seconds and came from the direction of the constellation Sagittarius. Amon was so stunned by its uniqueness that he circled it on the printout and scribbled "Wow," hence the name. What made the signal special was its strength and frequency, 1,420 megahertz, the natural emission frequency of hydrogen, the universe's most abundant element. This frequency is a logical choice for alien transmissions, since hydrogen is a cornerstone of chemistry and physics. Despite decades of follow-up searches, the signal has never been detected again, leaving scientists puzzled. Some suggest it could have been caused by natural phenomena, like interference from a passing satellite or Earth-based equipment, but those explanations haven't panned out. Others speculate it might have been a genuine extraterrestrial signal, though there's no hard evidence to back that up. Level 2. The water's surface Triton's capture. Triton, Neptune's largest moon, is a standout due to its peculiar orbital behavior, suggesting it didn't form alongside Neptune but was captured by its gravity. Unlike most moons in the solar system, which orbit in the same direction as their planet's rotation, Triton follows a retrograde orbit, moving opposite to Neptune's spin. This hints that Triton wasn't born near Neptune in the planet's nebula, but was once a free-roaming object, likely from the Kuiper Belt, a region beyond Neptune filled with icy bodies. The theory goes that Triton wandered too close to Neptune, and the planet's powerful gravity snagged it, locking it into orbit. Over time, Triton's orbit became more circular, but its backward path is a telltale sign of its capture. This also explains some of Triton's quirks. Its surface is covered in young, icy terrain, pointing to recent geological activity. It even has geysers spewing nitrogen gas into space, likely powered by internal heat from tidal forces caused by Neptune's gravity. Those same forces are gradually slowing Triton's orbit, which could lead to instability or even its eventual destruction. Heat death of the universe. The heat death of the universe, also called the Big Freeze, is a leading theory about the universe's ultimate fate. It's rooted in the second law of thermodynamics, which says systems naturally trend toward maximum entropy, or total disorder. In this state, all energy would be evenly spread out, leaving no usable energy for work. That would halt all macroscopic processes, from star formation to any dynamic activity. In the heat death scenario, the universe keeps expanding, cooling, and thinning out over unimaginable timescales. Stars burn through their nuclear fuel, fade, and turn into cold remnants like white dwarfs, neutron stars, or black holes. Even black holes, per Stephen Hawking's theory, will eventually evaporate via Hawking radiation, though that'll take far longer than the universe's current age. Once energy is uniformly distributed, stars will stop shining, and matter will be scattered across an ever-expanding cosmos. The universe will become uniformly cold, dark, and devoid of thermodynamic activity. No temperature or energy gradients mean no processes, not star formation, not life, not even new structures. The heat death is projected to hit in trillions of years, a timescale beyond human comprehension. It's a grim, irreversible end to the universe's evolution, leaving a nearly empty, structureless, lifeless void. Nibiru. Nibiru is a term that gained traction from doomsday theories claiming a rogue planet X is hurtling toward Earth. The idea first popped up in Zecharia Sitchin's 1976 book, The 12th Planet, where he argued that ancient Sumerian texts described a mysterious planet called Nibiru. Sitchin claimed it follows a highly elliptical orbit, swinging through the solar system every 3,600 years, and was home to an ancient alien civilization called the Anunnaki, who supposedly visited Earth long ago. But Sitchin's ideas don't hold water with scientists or archaeologists. His interpretations of Sumerian texts have been heavily criticized and debunked, with no evidence for Nibiru or alien visits. The Nibiru cataclysm theory suggests this planet could trigger a global disaster, like a collision with Earth. These ideas spiked around 2012, tied to the end of the Mayan calendar on December 21st, 2012. Spoiler: that year came and went with no apocalypse. Astronomers have found no large objects or planets on orbits threatening Earth. Modern studies of the solar system's outer reaches show no sign of such a body. Given what we know about orbital mechanics, Nibiru's existence is highly unlikely. Arecibo message. On November 16, 1974, the Arecibo Observatory in Puerto Rico beamed a radio message toward the globular star cluster M13, about 25,000 light-years away. The 169th second transmission consisted of 1,679 binary digits, ones and zeros. That number wasn't random. It's the product of two prime numbers, 23 and 73, allowing the data to be arranged in a 23 by 73 or 73 by 23 grid. When decoded correctly, it forms a visual message with info on numbers 0 to 10, the atomic numbers of key elements: hydrogen, carbon, nitrogen, oxygen, phosphorus, in DNA, a human figure, Earth's position in the solar system, and a diagram of the Arecibo telescope. Fun fact: the message wasn't really about contacting aliens, but more about showing off humanity's tech prowess. Even if someone out there receives and decodes it, a reply wouldn't reach us for tens of thousands of years. COBE, Cosmic Background Explorer. COBE was a NASA observatory dedicated to studying the universe's cosmic background radiation. Its biggest breakthrough was detecting tiny temperature fluctuations in the cosmic microwave background. These minute variations reflect early density differences that later grew into galaxies and other large structures. Despite their small scale, these fluctuations were key to understanding how a uniform universe turned into the complex cosmos we see today. COBE also confirmed that the cosmic background radiation spectrum, matches an almost perfect black body curve, a major win for the Big Bang theory. These findings solidified the idea that the universe started as a hot, dense state and has been expanding and cooling ever since. Gravitational lensing. Gravitational lensing is when a massive object, like a galaxy or black hole, bends the path of light from a more distant source, such as a star or galaxy. Predicted by Einstein's general theory of relativity, it happens because mass and energy warp space-time. As light passes near a massive object, its path curves, like light through a lens. This can magnify, distort, or even split the light into multiple images of the same source. Gravitational lensing is a powerful tool for astronomers, letting them spot objects too far or faint to see otherwise. It can amplify light, making distant objects brighter and more visible. It also helps detect invisible matter, like dark matter, which doesn't emit light, but exerts gravity that bends light from background objects, revealing its presence. The most striking form is strong lensing, where light from distant objects forms arcs or complete rings, called Einstein rings. Gravitational lensing not only backs up Einstein's theory, but also provides data on mass distribution in the universe, including dark matter, and lets astronomers probe the farthest reaches of the cosmos. Fermi Paradox. The Fermi Paradox is one of the juiciest topics on this iceberg. By the way, I've done a whole iceberg breakdown on paradoxes. You can check it out via the link in the top right corner. But for now, let's dive into the Fermi Paradox. It's the contradiction between the high likelihood of extraterrestrial life and the complete lack of evidence or contact with other civilizations. The term stems from a 1950 conversation where physicist Enrico Fermi asked his colleagues, "Where is everybody? Our Milky Way galaxy has billions of stars, many with planets that could support life. Yet, after decades of searching, we've found no signals or clear signs of alien life. The sheer scale of the universe makes life elsewhere seem almost inevitable." In 1961, astronomer Frank Drake came up with an equation estimating the number of communicative intelligent civilizations. It suggests there should be plenty out there, so why haven't we found any? Theories abound. Maybe intelligent life is super rare, or civilizations wipe themselves out or fall to catastrophes. Perhaps they avoid contact out of caution or a non-interference policy. Another idea: alien life is so different from us that we can't recognize their signals or traces, or they're just too far away and our tech isn't advanced enough to detect them. Earth doesn't orbit the sun. The claim that Earth doesn't orbit the sun is a misunderstanding of our solar system. Of course, Earth orbits the sun. We learned that in grade school. This idea comes from the heliocentric model proposed by Nicholas Copernicus in the 16th century. It places the sun at the center, with planets, including Earth, orbiting it due to the sun's gravitational pull. Earth's orbit isn't a perfect circle, but an ellipse, like an oval. The sun's gravity keeps Earth from falling in or flying off into space, and its orbital motion maintains the balance. Before Copernicus, the geocentric model held that everything revolved around Earth. Maybe the Earth doesn't orbit the sun idea is a throwback to that outdated view. But science, thanks to Copernicus, Galileo, and Newton, debunked that centuries ago. So, if someone says Earth doesn't orbit the sun, just remind them we settled that debate a long time ago. Haumea. Haumea is a dwarf planet on the outskirts of our solar system, in the Kuiper Belt, a region beyond Neptune packed with icy bodies and other dwarf planets. Haumea stands out for its location and its weird shape. Unlike most round celestial bodies, it's an elongated ellipsoid like a rugby ball or oval. This odd shape comes from its super-fast rotation. It spins fully in just 4 hours, making it one of the quickest spinning large objects in the solar system. Discovered in 2004 by astronomers using the Subaru telescope in Hawaii, Haumea was officially classified as a dwarf planet in 2008, by the International Astronomical Union. Its longest axis stretches about 1,600 kilometers, making it one of the largest known Kuiper Belt objects. Haumea has two moons, Namaka and Hi'iaka, named after Hawaiian goddesses. Its surface is mostly water ice, with a rocky core and possibly a thin atmosphere. Its composition and rapid spin suggest it formed after a collision with another large object long ago, which gave it its stretched shape and lower density compared to similar-sized bodies. One of Haumea's mysteries is its surface, which may be constantly changing. Its fast rotation could trigger active processes, like forming new ice deposits or refreshing surface structures. Retrograde Venus. Venus is often called upside down because of its unusual rotation. Unlike most solar system planets, Venus spins in the opposite direction of its orbit around the Sun and Earth's rotation. If you stood on Venus, the Sun would rise in the west and set in the east, totally backward from Earth. This is called retrograde rotation. Plus, Venus spins incredibly slowly, taking about 243 Earth days for one full rotation, making its day longer than its year, which lasts 225 Earth days. This slow backward spin makes Venus unique. Its axis is also nearly vertical, with a tilt of just 3 degrees compared to Earth's 23.5 degrees, so Venus doesn't have seasons like Earth. Its thick atmosphere, full of carbon dioxide and sulfuric acid clouds, plus scorching surface temperatures, makes it one of the harshest planets in the solar system. Scientists still debate why Venus spins this way. Some think a massive collision long ago flipped its axis. Others suggest gradual gravitational effects could be the culprit. Level 3. The Shallows. Moon destruction for Saturn's rings. One theory suggests Saturn's iconic rings formed from the destruction of a moon or another celestial body, not our moon, but one of Saturn's. It's a plausible explanation for the ring's origin. Made of countless particles, from tiny dust grains to big boulders, the rings are mostly ice with some rocky bits. They sit within Saturn's Roche limit, a zone where the planet's tidal forces are so strong they can tear apart a body, preventing it from staying whole or forming into one. If a moon or asteroid got too close, Saturn's tidal forces could have overwhelmed its own gravity, shattering it into fragments that spread out to form the ring system. Saturn's rings are thought to be relatively young, maybe a few 100 million years old, making the moon destruction idea likely. Other theories suggest the rings could be leftover material that never formed a moon or resulted from gravitational interactions with other bodies. Big Crunch Theory. The Big Crunch is a hypothesis about the universe's possible
Big Crunch
end.
theory.
It suggests that the expansion sparked by the Big Bang could slow down, stop, and reverse, causing the universe to collapse back into a super-dense hot
causing
point.
the universe to collapse
This
back
hinges
into a
on the
super-dense
idea that the
hot point.
gravitational
This
pull of
hinges
all
on the
the
idea
universe's
that the
matter
gravitational
could
pull of all
overpower
the
the forces
universe's
driving
matter could
expansion.
overpower the forces
If
driving
the
expansion.
universe's density, especially with dark matter, is high enough, gravity could halt expansion
If the
and trigger
universe's
collapse.
density,
In a
especially
big
with
crunch,
dark matter,
galaxies
is high enough,
would start merging,
gravity could halt
stars
expansion
would collide,
and trigger collapse.
and temperatures
In a
would
big
skyrocket.
crunch, galaxies would
In the
start
final
merging,
moments,
stars
all
would collide,
matter and energy would
temperatures would
compress
skyrocket.
into a point,
In the final
possibly
moments,
resembling the
all matter and
pre-Big
energy
Bang
would
state.
compress into a
But
point,
recent
possibly
observations show
resembling
the
the
universe is
pre-Big Bang
expanding
state.
faster,
But recent observations
thanks to
show
dark
the universe
energy.
is expanding
This
faster.
1990s discovery makes the Big Crunch less likely. Many scientists now favor
Thanks
the
to
Big
dark
Freeze,
energy.
where the universe
This
expands
1990s
forever,
discovery
growing
makes the
colder
Big Crunch
and
less
emptier.
likely. Many scientists now
WMAP,
favor the Big Freeze, where the universe
a
expands
NASA
forever,
spacecraft,
growing colder
studied
and
the cosmic
emptier.
microwave background
WMAP,
radiation from the Big Bang.
WMAP, a NASA
This
spacecraft,
radiation is like a
studied the cosmic
snapshot of the
microwave
universe
background
at
radiation from the Big Bang.
380,000 years
This
old,
radiation is
when it
like a
became
snapshot of the
transparent to
universe
light.
at 380,000 years old.
WMAP's
When it
main
became
goal
transparent to
was to
light.
measure tiny temperature
WMAP's main goal
fluctuations
was to
in this
measure tiny
radiation
temperature
with high
fluctuations
precision.
in this radiation with
These
high
measurements
precision.
refined our understanding of the universe's age, composition, and structure. A key finding was pinning the universe's age at about 13.8 billion years. WMAP also nailed down cosmological parameters, showing the universe is 68% dark energy, 27% dark matter, and just 5% ordinary matter. Its detailed map of the cosmic background radiation revealed temperature variations tied to the seeds of galaxies and large-scale structures. These fluctuations, formed moments after the Big Bang, led to the complex universe we see today. 10th planet. The 10th planet is a hypothetical body beyond Pluto's orbit, speculated about in studies of the solar system's outer regions. The idea gained traction in 2005 with the discovery of Eris, a large icy object in the Kuiper Belt. Initially thought to be bigger than Pluto, Eris sparked debates about whether it qualified as a full planet. This also questioned Pluto's status as the 9th planet. In 2006, the International Astronomical Union redefined planet, reclassifying Pluto and Eris as dwarf planets. This settled the debate, categorizing Kuiper Belt objects like Eris as dwarf planets, not full ones. Still, 10th planet sometimes refers to hypothetical large objects in the solar system's distant reaches. Some astronomers think planets as big as Earth or larger could be hiding out there. Face on Mars. The face on Mars is a famous image snapped by NASA's Viking 1 in 1976. Taken in the Cydonia region, it shows a structure resembling a human face, sparking wild speculation about ancient alien civilizations on Mars. The image's clear features, eyes, nose, mouth, fueled theories that intelligent beings built massive monuments, like Egypt's pyramids or Easter Island statues. The face became a pop culture icon, boosting belief in Martian life. But later studies debunked it. Higher resolution images from the 1990s showed it's just a plateau or mesa with no artificial features. The face-like shape came from shadows, lighting, and the low resolution of Viking 1's camera. It's a classic case of pareidolia, where the brain sees familiar patterns where none exist. Pluto-Charon double planet system. The Pluto-Charon system is often called a double planet due to the unique interplay between the dwarf planet Pluto and its largest moon, Charon. Unlike most solar system moons, which orbit far from their planets, Charon is so large relative to Pluto that their gravitational dance isn't your typical planet-moon setup. Charon's diameter is about 1,200 kilometers, half of Pluto's, making it the largest moon relative to its planet in the solar system. Their shared gravitational pull means the system's center of mass lies between them, not inside Pluto. So Pluto and Charon orbit a common point, a hallmark of a double planet system. They're also tidally locked, always showing each other the same face, like how Earth's moon always faces us. This sync creates a harmonious dance around their shared center. These traits have sparked debates about calling Pluto and Charon a double planet system, but Pluto's dwarf planet status keeps it from being officially classified as such. Nemesis. Nemesis is a hypothetical star some astronomers propose to explain periodic mass extinctions on Earth. Suggested in the 1980s by scientists at the University of California, led by physicist Richard Muller, they theorized the Sun might have a distant stellar companion, an unseen twin, affecting comet orbits in the Oort cloud. The idea is that Nemesis could pass through the Oort cloud every 26 million years, disrupting icy bodies and sending some toward the inner solar system, potentially crashing into Earth. Such impacts could cause mass extinctions, like the asteroid strike believed to have killed the dinosaurs 66 million years ago. The Nemesis theory ties to claims of cyclic extinction patterns in the fossil record, but decades of searches have found no evidence of such a star. Astronomers have used various observation methods with no luck. Later studies also questioned the idea of regular extinction cycles, suggesting they might be statistical flukes, not the result of a systematic cause. Big Bounce Theory. The Big Bounce Theory offers an alternative view of the universe's origin and fate. Unlike the Big Bang's single starting point, it proposes the universe cycles through phases of expansion and contraction. In this model, the universe repeatedly collapses into a singularity, an infinitely dense, hot state, then bounces back, expanding into a new cosmos. Each cycle might alter the universe's physical properties, making every bounce unique. This cyclic nature suggests a universe with no clear beginning or end, eternally expanding and contracting. The Big Bounce is often explored in quantum gravity and string theory, aiming to merge quantum mechanics and general relativity. During contraction, gravity pulls everything together, but quantum effects might prevent a total collapse, letting the universe rebound into a new expansion phase. Quantum cosmology supports this, suggesting quantum effects play a big role at tiny scales. Golf on the Moon. Golf on the Moon became a reality in 1971 during the Apollo 14 mission, when astronaut Alan Shepard, the first American in space, pulled off a quirky experiment. Using a modified golf club he smuggled aboard, Shepard hit 2 golf balls while in his bulky spacesuit. The balls flew much farther than they would on Earth. The first went about 183 meters, the second even farther. This iconic moment, though not part of the mission's official science plan, is one of the most memorable in space exploration history. Apollo 14's main tasks were collecting geological samples, setting up equipment, and studying the lunar surface. Level 4. Dark Waters. Martian Spoon. The Martian Spoon is an object spotted by NASA's Mars rover, exploring the planet since 2012. It's a small rock shaped eerily like a spoon. When images hit the internet, they stirred excitement, with conspiracy theorists claiming it was proof of alien civilizations or ancient Martian artifacts. But NASA scientists explained it's just a natural formation, sculpted over millions of years by Mars' harsh conditions. Wind, erosion, and sand blasting created the spoon-like shape. Penis drawing on the Moon and the Lunar Museum. The penis drawing on the Moon is a quirky footnote from the Apollo 12 mission, NASA's second manned lunar landing in 1969. Alongside the lunar module, a tiny ceramic disc called the Lunar Museum was secretly brought to the surface. Curated by artist Forrest Myers, it featured miniature works by artists like Andy Warhol and Robert Rauschenberg. Among them was a simple penis sketch, snuck in without NASA's approval. The stamp-sized disc was left on the Moon as a conceptual art piece. Its existence went unnoticed for decades due to its tiny size and secrecy. When revealed, reactions were mixed. Some saw it as a juvenile prank, others as a bold artistic statement. NASA was unaware of the drawing during the mission, and its small size made it invisible to astronauts on the surface. Center of the universe. The idea of a universe with a center has captivated humanity for centuries, from scientific and philosophical angles. Ancient cultures often placed Earth, or their specific civilization, at the cosmos's heart, reflected in the geocentric model by astronomers like Claudius Ptolemy. But in the 16th century, Copernicus showed Earth orbits the Sun, not vice versa. Galileo and Kepler's work backed this up, and as astronomy advanced, the notion of a single cosmic center faded. In the 20th century, Edwin Hubble's observations revealed galaxies moving apart, signaling an expanding universe. This led to the realization that the universe has no center in the traditional sense. Alien life beneath Europa's crust. Europa, one of Jupiter's moons, is a top candidate for finding extraterrestrial life in our solar system. Beneath its thick, icy crust likely lies a liquid ocean, kept warm by tidal forces from Jupiter's gravity. This ocean might interact with Europa's rocky core, creating conditions similar to Earth's hydrothermal vents, where microbes thrive without sunlight, using chemical reactions for energy. Cracks and ridges on Europa's icy surface suggest exchanges between the ocean and surface. Future missions like NASA's Europa Clipper will study the surface composition, ice thickness, and possible signs of biological activity. If life exists under Europa's crust, it would be a game-changer, reshaping our view of life beyond Earth. Russell's teapot. Russell's teapot is a philosophical analogy from British philosopher Bertrand Russell in 1952. He imagined a tiny teapot orbiting the sun between Earth and Mars, too small for telescopes to spot. Russell argued that if he claimed it existed without proof, no one would be obliged to believe him. The analogy stresses that the burden of proof lies with the person making a claim, not those doubting it. Human ashes beyond the solar system. In 1998, the ashes of Gene Roddenberry, creator of Star Trek, became some of the first human remains sent into space. Through the Celestis Memorial Spaceflights program, a small portion of his cremated ashes was placed on a spacecraft that left the solar system. Vacuum. A vacuum is a space with very little matter or pressure far below Earth's atmosphere. In space, it's nearly a perfect vacuum, with only stray hydrogen atoms across vast distances. But no space is truly empty. Quantum fluctuations, called vacuum energy, create virtual particles. Vacuums are crucial in science, from lab experiments to space research. For example, in a vacuum, objects fall at the same speed regardless of mass, as Galileo showed. In space, a vacuum affects the human body. Without pressure, bodily fluids could boil, making protective gear essential for survival. Big Bang and quantum tunneling. The idea that the Big Bang was triggered by quantum tunneling is a fascinating blend of quantum mechanics and cosmology. Quantum tunneling lets particles pass through energy barriers they shouldn't, per classical physics. Some theories suggest the universe emerged from quantum fluctuations in a vacuum, possibly tied to inflation, a rapid expansion phase in the universe's first moments. In this model, the universe tunneled from a high-energy, dense state to its current form. Stephen Hawking and James Hartley proposed the no-boundary hypothesis, suggesting the universe has no clear starting point, with time emerging from a quantum fluctuation and the Big Bang as a tunneling event. White holes. White holes are hypothetical opposites of black holes. While black holes suck in everything, including light, white holes would spew out matter and energy. They arise in mathematical solutions to Einstein's equations, particularly the extended Schwarzschild solution. Essentially, a white hole is a black hole's reverse. Some theories link white holes to black holes via wormholes, suggesting matter entering a black hole could exit a white hole elsewhere in the universe. But white holes remain theoretical. They could disrupt causality, allowing events to occur backward, leading to paradoxes. They also clash with the second law of thermodynamics, as they'd reduce entropy, impossible in a closed system. Pocket universes. Pocket universes, or bubble universes, are a hypothesis in cosmology and theoretical physics, proposing small, self-contained universes within a larger cosmos. Each pocket universe is an isolated bubble with its own physical laws, properties, and space-time structure. The idea ties to eternal inflation theory, where, after the Big Bang, the universe underwent exponential expansion. Inflation might have continued in some regions, spawning new pocket universes within a broader inflationary space. Each could have unique physical constants, laws, or even dimensions. These universes are fully isolated, so events in one don't affect others, and each evolves independently. Formation might stem from quantum fluctuations or other processes. Though intriguing, pocket universes are purely hypothetical. No direct evidence exists, and proving or disproving them is tough. Still, some scientists think the concept could explain cosmic puzzles, like why our universe's physical constants are finely tuned for life. If countless universes exist, it's less surprising we're in one suited for life. Level 5. The Abyss. Origin of Europa's pinkish-brown hues. The pinkish-brown hues of Europa, Jupiter's moon, have long puzzled scientists, remaining a key mystery in planetary science. Europa, one of Jupiter's 4 largest moons, is covered in a thick, icy crust, beneath which lies a global ocean of liquid water, making it a prime target for studying potential alien life. The unusual coloring, especially in cracks and ridges, is a fascinating phenomenon that could shed light on Europa's geological and chemical processes. These pink and brown shades are most noticeable near the equator or along fractures and faults. Their concentration in specific surface features suggests a link to geological activity or interactions with the subsurface ocean. One theory points to salts, like sulfates and chlorides, mixed with water and ice on the surface. These salts likely rise through cryovolcanic activity or geysers ejecting material from the ocean below. On the surface, they're bombarded by intense radiation from Jupiter, altering their chemical makeup and creating the reddish or brownish tinge. High-energy radiation from Jupiter's magnetic field breaks down molecules, forming compounds like tholins, complex organic molecules tied to red and brown hues. Europa's ocean, likely in contact with its rocky mantle, may be rich in chemicals that migrate through cracks, mix with ice, and form these colors under radiation or environmental factors. Exact location of the WOW signal. The exact source of the WOW signal mentioned earlier remains unknown. It's one of the most famous enigmas in the search for extraterrestrial intelligence. Lasting 72 seconds and coming from the direction of Sagittarius, its intensity, frequency, and duration were unmatched. Despite extensive efforts, it's never been detected again, leaving its origin a deep mystery. Pinpointing its distance is a major challenge. It came from an area near the star Tau Sagittarii, but wasn't clearly tied to that star or any known object. Without a repeat signal, identifying its source or location is nearly impossible. Some speculate it was an alien transmission, given its narrow frequency band and lack of a natural explanation, but that's purely hypothetical. The WOW signal remains a one-of-a-kind anomaly. Oumuamua. Oumuamua, the first confirmed interstellar object to visit our solar system, was discovered on October 19, 2017, by the University of Hawaii's Pan-STARRS 1 telescope. Its name, from Hawaiian, means messenger or scout. Moving on a hyperbolic orbit, it confirmed its origin beyond our solar system. At its closest approach to the Sun, it sped along at about 87.3 kilometers per second. Estimated at 230 meters long and 35 meters wide, its elongated shape is unusual. It spins every roughly 8 hours. Theories about Oumuamua's nature vary. Some suggest it could be an artificial object, like an alien probe, but most researchers lean toward a natural origin, an asteroid or comet with odd shape and behavior. Its discovery was a landmark in astronomy, marking the first recorded interstellar visitor to our solar system. That's it for now.